Hey guys, this is Module 8, Statistical Reasoning in Everyday Life. Okay, so why do we need statistics? A lot of us don't like math, but statistics are really necessary in psychology because they allow psychologists to measure variables and basically interpret those results. Now, in general life, you're going to hear people say things like 20% of people think this. Lots of people like to throw big round numbers at us. Most of the time, those statistics that people are just throwing around like that, especially if it's a rounded number like that, is probably not super accurate. The take home point here is that you should doubt big, round, undocumented numbers and really push them to see that data that they're citing. Now, we as critical thinkers, we need to understand the basics of statistics so that when people do present us with data, we actually know what we're looking at and what exactly that means. So we need it in order to be scientifically literate. Okay, so first of all, we have descriptive statistics. Descriptive statistics is basically data that is used to measure and describe characteristics of groups. Okay, this just describes what's going on. So example, when we look at the class scores of a test, oftentimes, like I post on the board, what the class averages are. A class average is a mean, and a mean is an example of a descriptive statistic. So these measures of central tendency, these are those three descriptive stats that allow us to get some information about the data. So the first is the mean. This is basically the average. And this measure is the one that is most impacted by extreme scores. So if you had, let's say, a data set that had a range of 1 to 100, the mean may not be the most helpful piece of information, depending on the rest of the data. Because if there's like 20 ones and then 100, a better measure there would probably be the mode, which is the most frequently occurring score, or even the median, which is the midpoint of the score. Now, you probably all know this. This is just kind of a review, but an easy way to use descriptive stats is by putting them onto a bar graph, which is what we call a histogram. Now, you have to be careful to read the scale labels, though. Sometimes, if you're not paying attention, the scale labels, so on the X or the Y axis, on the Y axis or the X axis, they can be a little bit deceiving. So you have to make sure that you're actually paying attention to what exactly it's telling you. Now, in a bell-shaped normal distribution, this is what that would look like. This is called a normal curve. The mean, median, and mode are going to be clustered right around the middle. Okay, they're going to be all around the same. That is in a normal curve. When things are skewed, this makes the mean as not the best indicator of what's happening in the data set. So, like, for example, when Microsoft co-founder Bill Gates sits down in an intimate cafe, the average customer instantly becomes a billionaire, but the median customer's wealth remains unchanged. So when you have data that is skewed, the mean is not usually the most helpful piece of data. You have to look at other pieces. So things you need to know are positive skew and negative skew. So in this example, we have a negative skewed set of data. What that means is that there is a tail that is going towards zero. So there's more scores clustered closer to zero than there are towards the mean. With a positive skew, it's just the opposite. There are more scores clustered away from zero than clustered near the mean. And so that can tell us more about the data. Like, let's say, for example, let's say the mean on a test we took in a class was 70%. But there were a lot more lower scores. That would probably be a negatively skewed test. So yeah, you will need to know what these look like. So negative skew has the tail going towards zero. Positive skew has the tail going away from zero. And this is a normal curve. Okay, some measures of variation. So this is more descriptive statistics. The reason why we use these measures is that it allows us to know something about the amount of variation in the data. Basically, how similar or diverse the scores are. And averages are derived from scores with low variability. They tend to be more reliable than averages based on scores with high variability. So basically what this means is, let's say my first period class, the average is 75%. If the range only goes from, let's say, a 70 to an 80, we can have pretty good guesses. We could make some guesses that most people are going to fall in that, right? Whereas if I could make a pretty good guess that maybe a person would score like a 77, let's say. Whereas if the data is very large, if there's a lot of variation, it's a lot harder to make those accurate predictions. So a really easy way to measure variation would be the range, which is the gap between the highest and the lowest score. Then a more sophisticated method, which psychologists and researchers use, is called the standard deviation. And this is basically a measure of how much the scores vary around the mean score. So, for example, at our school, which has a higher socioeconomic status than a lot of other schools in our district, the standard deviation for income would likely be smaller than at a school who has a lot of variability in the income of their families. So that would mean that we would have a smaller standard deviation than a school that has more variation. Now, you need to know these percentages. So let's take IQ, for example. Average IQ is 100 points. The standard deviation is 15 points. So within 15 points of either above or below, 68% of people fall within that. Okay, so if you score 115 on a IQ test, that means you are one standard deviation above the mean. Now, let's say you score a 130, then you are two standard deviations above the mean. Okay, that would mean you are in the gifted category. If you score above that, you would be considered genius. And the same goes for the opposite way. So if you scored an 85, that would be considered below average IQ. If someone scores a 70, that's when we would start considering that they probably have some mental delays. Now, this is what you really need to write down. So within one standard deviation of both sides, 68% of people fall within one standard deviation. If you score within two standard deviations, that means 95% of people are going to fall within that range. And then within three standard deviations, 99.7% of people are going to fall within that range. So that's why, if a person scores above a 130, which is two standard deviations above the mean, they're considered a genius because they are in the top 2.5% of IQ scores. So this is our natural bell curve. You do need to know these percentages. This is what a bimodal distribution looks like. You see that there are two modes here, 12 p.m. and 7 p.m. is when it looks like this store has its most customers. So these are just some graphs that you need to know and understand. Mainly this though, and we'll go over this more in class too. Okay, inferential statistics. So beyond just describing the data, psychologists want to be able to make some predictions with it. And so we have to ask, how confidently can we infer that an observed difference between, let's say, my control group and my experimental group is not just a fluke. So to help us, we use what we call inferential statistics, which is numerical data that allows one to generalize and apply that data to the larger population. So these are some things we have to consider when looking at a data set to see if it's safe to generalize to the larger population. First of all, we have to look and see at the sample. Is the sample representative or is it biased? Did we get a random sample? Did we use random assignment? We have to look at the sample. The second is we have to understand that generally, if there's less variability in the data set, then it's probably more reliable than one that's super variable. And then lastly, more cases are better than fewer. A larger data set is a better indicator of an actual effect of a treatment than just a few people studied. So when the sample averages are reliable, once they've met all those characteristics, and when the difference between them is relatively large, we would say that this difference has statistical significance. Basically, what this means is that let's say I find the effect that breast milk increases IQ when compared to formula. In order for that to be called statistically significant, the difference in IQ scores between the babies breastfed versus the babies fed with formula needs to be a big enough difference to be statistically significant. And also, it has to be very unlikely that it's just due to chance. So psychologists have to be confident enough to say we're 95% sure or more that this difference between these two groups is not due to chance, but rather due to the effect itself. So this is what we call statistical significance. We measure this with what we call p-values, and we'll go over that more in class. But just generally, you have to know when we're talking about statistical significance, we basically are saying the differences between the two groups, the experimental group and the control group, were large enough, and the likelihood that it was due to chance is low. Okay, now I'd like you to test yourself, and I'll see you soon. Bye.